All right, let's keep going with our 9.6 notes. So we've seen how to solve some really simple, just take a square root kind of problems, but sometimes the problems will be a little bit more complicated, so we'll need to isolate the x squared, which just means we want to get the x squared by itself before you take the square root of both sides of the equation. Follow the inverse and opposite order of operations. If the radicand, and what all that means is the number inside, okay, so number inside radical, just messed that up, I want not an insider, inside the radical, is not a perfect square. Leave the solutions as simplified radicals. I actually I think those are from some old notes. I've actually taken that out. I've tried to make these all nice. So like square root of 196, 13, square root of 81, 9. So I tried to make them all perfect squared. But if you do just come across one of those, just leave it in the radical symbol and do a plus and minus. All right, just in case, but I don't think I did do that. All right, on this one, what we're going to do is you can see it says x squared minus 36 equals 0. So all we want to do is we want to make them look more like this. So it's a really simple fix. We're just going to add 36 to both sides of this equation, and I get x squared equals 36. And if I take the square root of both sides now, I get x equals negative 6 and positive 6. So just like that. Right? So then you might also have something like this next one, where we've got 5 times x squared. So we divide by 5, we divide by 5, and I get x squared, and 5 goes into 125 25 times. Try to make those easy. Square root, oops, and I get x squared equals, not x squared, boy, I'm getting carried away. All right, x squared equals negative 5 and 5. Okay, so x equals negative 5 and 5. I think I still said x squared. All right, last one. This one's 2 steps. All right, to get this by itself, we have, we're going to subtract the 6 from both sides, and I get negative 3x squared, and I get 21. Divide both sides by negative 3, and I get x squared equals negative 7. Okay, so here's one of those where I don't know the square root of 7. Oh, but wait a minute. Something else is going on here too. So I'm going to see if you guys can figure it out. Let's see if you can tell me what this answer is. All right, welcome back. I hope you figured it out. It's actually no solution, because we can't take the square root of a negative number. So this one actually has no solution. So watch out for those. They're not always the last one, by the way. Okay, that just is a coincidence. Okay, let's go ahead and flip over a paper and do a couple more. So moving on to side 2, we've got solving a quadratic equation by factoring. Most quadratics are trinomials or have a linear x term and cannot be solved as easily as they were in the previous examples. For example, try to solve for the x in the following problems. Okay, so here's the thing. I just wanted to show you that this isn't going to work. So if I do, like maybe I could add the x here to both sides. And you know what? You can't really see that yellow. I'll zoom in. I think it'll be okay. So if we add the x to both sides, okay, I get 12x squared equals x. Okay, and then what do? Do I divide by the 12? I still have, remember the whole point of solving for x is I really want it on the same side. So this isn't going to work. Now, some of you might try some other things, but I promise you, it just doesn't work. Okay, doesn't work. Epic fail. All right. Same problem with this one, okay, with B. I could add the 42 to both sides. You can add 42 to both sides, but it's still not going to help me because I'm not going to have the x together. I want to solve for a single x, not two x's. So you might be asking yourself, well then how come we could do all those really easy ones on the other side? And the difference is see, this one has an x squared and an x. This one has an x squared and an x. It's got that linear, that single x in it. The ones on the other side, so I flip to side 1, you can see an x squared, a constant, x squared, a constant, x squared, two constants. No single x to the first power. That was the key difference. Alright, so just wanted to show you the difference between these two problems so you know what to do when you're doing the homework. If there's an x, just an x with the x squared, you're going to have to do the next method that we're going to do on the last set of notes here. So watch out for these problems. You need to be able to tell the difference between the two.